Oh, welcome back, my dear students. We are back into the new video where we are continuing our discussion in the sets. Right, remember by the previous video, following the link down here, we will introduce ourselves into the sets and we have discussed a lot about it, definition itself, the symbols, and also how best we can present the sets in any two of the ways. One directory, secondary, the set build annotation. So can you please revisit the discussion by the link down here? You should expose to site videos before you take any attempts to today's video. That's the discussion. Right. We're wasting much of time. Today's business is also just simple. It's the same issue about the set theory. Right? So today we'll just be there exposed into the other sections, which are not all that new again. This is about the universal set. Universal set. We'll discuss something about that. And after, we'll also look at something about the types of other sets, like say talk of the union of sets, union of sets. Then we talk of the intersection over sets. Right. And if time allows, we'll be able to be exposed into what we call the what? The Venn diagram. Right. Not forgetting something about the complement of a set. You know what? This is just a theory, just a matter of discussion like that. That's the way our topic is all about. What is the universal set, union of a set, intersection of sets, complement of the set, and after a Venn diagram, and we go by that. But so quickly, let's begin by discussing something about what we call the universal set. Universal set. Right. If we talk of a universal set, that this is a universal. Universal is simply like a whole. In other way, we can define it just like a main set. So if we talk of a main or a whole, we're talking of a set that is there like a mother, a set that is carrying other sets is universal. For example, if we can have a set of a Form 3 class, it means in this case I'll be referring to the students themselves. Class Form 3. I'll be referring to the students themselves. So if I'll define a Form 3 class as a universal set, meaning that it's a main set, it means Form 3 class is a set that is carrying the other set. So for the Form 3 to qualify to be a mother set, you can be able to categorize the students into other minor sets. For example, if we talk of the class of Form 3, you'll bear with me that that class has got students. Some students are girls, some students are boys. So it's just like in one class, the students are already categorized into two groups. One is a set, maybe set of what? A, which is about girls. And another is a set what? Set B, which is a set of what? Boys. So both categories here are defining one thing. They are all students which are in the what? Form 3 class. So in this case, since Form 3 class is containing two sets, we can define Form 3 class as what? A universal set. It has got a set of girls, a set of what? Boys. So these two are minor sets which are found into the main set. This is just like a mother set. So this one is a what we call it a what? Universal set. Right, by area discussion, in this case, since set A of girls is found in Form 3 class, and set B of boys is also found in Form 3 class, then the two sets here, A and B, are referred to as subsets. So it means set A is a subset of what? Form 3 class. In Form 3 class is defined by a particular definition. It means this one, as far as it is a main set, it is a main set, the universal set, then that symbol comes in here to say that the universal set of a Form 3 class is referred to something like this. So it means this one here is the universal set of a Form 3 carrying minus set. Set A now be a subset of the universal set. Set B subset of a universal set. So that our write-up will be something like this. A, by this symbol, from what I indicated earlier, you'd say A is a subset of what? A universal set. And also here, talk of a B is also a subset of what? A universal set. Like that. That's how it goes. Right, so universal set is just like a mother set. Similarly, I may also have another example here of what? Set of natural numbers. Like say, for example, set of natural numbers. That one can be universal if that one contains other minor sets. For example, here, I have got this one representing the universal set of natural numbers which are less than 10. I'll talk of 1, 2, 3, 4, and talk of what? A 5, 6, 7, 8, the 9, like that. So this is the main set. In my universal set, what I expect is that this one should also be defined by other sets. So out of this, I can have other sets like maybe set A of natural numbers, such like 4, 6, talk of the 9, and another one, K, having elements like from the cell, not from somewhere. We talk of the 7, talk of 4, talk of a 1. Look at this here. I have got this, I have got this, I have got that. If I look at A as a set, it has got 4, 6, 9, which are contained in this set here. If I look at K, it has got 7, 4, 1. These are also elements which are contained in here. So, much that these sets are contained in here, we define these two sets as subsets of this one. So this one is regarded as what? Universal set. Right. Having known that, let us also try to understand when we talk of the union of a set. Right. Union of sets. Right. So now, you know what? The issues about sets are just like related, they're just connected. You talk of one thing, you talk of universal set. Out of the universal set, we can also describe issues about the union of sets. We may also talk of what? Intersection of sets. Out of the same, we can also discuss something about what? Complement of the set. So let me also take advantage of the same universal set with its subsets A and K to define what a union of the set is. Like, when you talk of the union of the set, in this case, by earlier discussion, you will be able to bear with me that the union of the set is recognized by a symbol which is like this. It's more like a U. Right, so in this case, how can we understand it better? Right, now look at this. I have got one example here. This is a universal set, like this, with these elements. And here I've got my set A, and also set K. Right? Set A has got these elements. Set A has got these elements. Set K has got these elements. When now talk of the union of the sets, here we are just referring it to the combination. Combination of elements of given sets. Right, combination. So just like anywhere, maybe you can have some sets, as much as you know there are elements. If you bring those elements together, what you have is just a union. More like you are joining. A better word here is combining. So if somebody here can ask you, can you find the union of set A and B? Set A and B. What simply means to say is just a matter of trying to combine the elements found in A and B aside. So what will be here will be something that will be like this. First, on how you're going to write the union of A and B. So what we'll write here, we'll write something like this. A symbol of this, which simply means union, and then B like that. So when you write like this, it means A union B. Right. So how does this one sound? It means what we want here is just like the elements which are found in A and B put together. So by this example, it means if the union of A and K, not B here, but let's talk of K, let me use the letter K, not B. Under that I like talking of a B, but rather here we're talking of a K. We have got this one is set M, this one is set K. Right. So set A has got elements 4, 6, 9. Set K has got 7, 4, and 1. So if we talk of the union of A and K, it simply means you have to take all the elements of A, which are 4, 6, and 9, and again elements of K, which are 7, 4, and 1, listed together. Right. So when you write, sometimes the order can be 4, you can begin with the smaller number. You compare in A and K, so you find that the number that you can start up with, you can talk of a 1, then you go to, the next small number is a 4, then you go to what? 6, and then 7, lastly you talk of a 9. Right, so when I write this symbol here in between A and K, it means A union K. What do we have? We have got 1, 4, 6, 7, 9. Right, so I have to make sure that all the elements in A and B has been what? Captured. But if there's an element which is found in both what? Both what is set in this case, that element is written once. Like say for example, if here I were to have maybe talk of an element talk of 9, and here there's also what? 9. When writing here, you don't repeat the 9 and writing another 9 like this. No, it's just like 9 has already been written. We're talking of one set here. So you don't repeat an element in lighter. Right, so here we just write a single 9 like that. Right, so please try to understand when you talk of the union of sets, we simply talk of the combination of elements of a given set. It can be 3 sets, it can be 2 sets, things like that. If there are 4 sets, for example, you have set A, you simulate A, union maybe K, union another set, D, you keep on writing maybe union F, things like that. So it means combining elements of F, D, K, and A together. Right, but don't repeat the light up of an element. Right, so that's what it means by union of sets. Right. Next, let us also talk issues about now intersection of the set. When you talk of intersection, how does this one differ from the union of sets? Right. So for intersection, I already defined this area to say when we talk of intersect, we talk of like say a common point, like say when lines are intersecting each other. Look at this and this line. This is the intersection point. If you talk of this point here, this is just like common. It's found, it's a point for both lines, this line and that line. The same way you talk of intersection, it sounds more like the same. That's a intersection of the set. We talk of elements which are found in given sets of discussion. Right. Meaning what? Look at this here. We still have an universal set with these elements here. We have said that set A is a subset of what? This universal set. Set K is also a subset of that. So it might happen that set A now has got other elements like talk of 7, right? Also have elements like what? A 4, like this. While set K has got 7, 4, and 1. You'll be able to see that if you look at set A and set K, there are some elements which are found in both, or set of common elements. Look at this. Here there's 7, here there's 7. Here there's 4, here there's 4. So which means 7 and a 4 are common elements. So the two elements, they form their set. And this set is known as the intersection of sets. Right. So how do you present that on the issue about the intersection of sets? So it would be something like this. Intersection of sets. Right. So here, let me just write this for you. This is set of common elements. Common elements from the given sets. Like, to mean what? For example, from what I've said here, set A has got these elements, set K has got these elements here. So just like now, what is it about intersection of A and K? So what we write here, we write A like this, that's the symbol, meaning A intersection K, and this gives us what? You write the elements which are contained in what? A and K at the same time. So I have highlighted here 7 and 4 that found in both sets. So intersection of A and K give us what? 4 and 7. Right. Right. So that's what it means here. So every time we consider issue about intersection of sets, we have to talk of this situation here. Please don't disturb with the symbol about what? Union. Union is the opposite of this one. So I have to repeat, union simply means combination of elements. But we talk of intersection, we are talking about the what? Elements which are found in both sets. We talk of the common elements. They form their own what? Set as such. Right. Last in the discussion here, we need also to understand fully about what it is described as a complement of a set. Complement of a set. Right. So it's all by what we studied earlier, where we were discussing about the symbols, different symbols in sets. Right. When we talk of a complement of a set, complement of a set. Right. We talk of talking about a set of elements which are not contained in a particular set under discussion. Right. Here is just a word not contained or found in a particular set. So this only works when we have a situation where we have an inverse set. Right. For example, we have an inverse set here defined by 1, 2, 3, 4, 5, 6, 7, 8, 9 natural numbers. And here I've got 2 sets. Set A, 4, 6, 9, 7, and 4. Let us remove this 4 here, has just been repeated. Right? We are supposed to just have a single 4 here. The 4 is already there. Right, so we are that time circling that one and this one here. Like that's 2, 4, 7, 7, and 4 by the intersection. Right, now we are talking of this is the inverse set. Have 1, 2, 3, 4, 5, 6, 7, 8, 9 as the natural numbers. And out of this set, we have got the subsets, which are A, set A, with 4, 6, 9, and 7 as elements, and set K with 7, 4, and 1 as elements. Now, if it comes to this situation here, complement of the set will be there asking you to give us a complement of set A. That will be the kind of questions. Complement of set K. So this will be in relation to a given universal set. Right. How will it be? From this definition, we say elements which are not contained in A. So it means you compare this set and that. What is not found here based on this complement of set K. You look at this set here. What is not found here? Okay? So it means you're going to compare this and the mother set, which is the universal set. Right. Like say, for example, somebody asks you to find the complement of A, and how you write, by the earlier discussion of the symbol, you write like this. A with an apostrophe on top. That means complement of A. What are the elements which are not found in A? That's what it means here. So it means the first thing you do, you come here and check what is in A. So you find that in A there's a 4, there's a 6, there's a 9. So when you come to universal set, this is a subset of the universal set. you'll be able to see that the 4 is this one here, the 6 is this one here, the 9 is this one here, and the 7 is that. So what is not found here are the numbers which are not underlined. So it means here we talk of a 1, a 2, a 3, we talk of what? A 5, we can also talk over 8. Right, so those elements are not contained in A, and they form a set which you would find as complement of A. So here, if I'm to list down the elements of complement of A, I'll write those numbers up there. 1, 2, 3, 5, and what? 8. And then close that with a curly bracket like that. Right. Similarly, if we are there to come up with the elements of the complement of set K, this is what we're going to write, a K and an apostrophe on top, like that. And then now, what do? I have to go to set K and check what type of elements are found in K. So in K, we have got 7, 4, and 1. Right. So if we go to the universal set, I'll see that this is 7, this is 4, this is 1. Right. So what is not here in K, you'd find that you have got all numbers which are not enclosed in the box. So here we'll be referring to 2, 3, 5, 6, 8, and 9. So those are the numbers that are going to form complement of K. So if I'm to write the list of the elements of complement of K, I'll have numbers such like you talk of what? We'll talk of excluding a 7, 4, and a 1. So here I'll list what? 2, 3, 4, not 4 in this case because 4 is already referred here. And here we talk of what? 5, 6, then 8, and 9. See that? Right. So that's what it means by complement of the set. Right. So students, what we have discussed here, we have discussed the universal set. We understand what the universal set is all about now, just like the main set. Out of which we have got subsets like A and K. Right. Next, what we have also discussed here is about the union of set. The union of set, I'll just repeat, is a combination of elements. It's just a set of the combination of elements of sets under discussion. By the example I gave you earlier, you can go through that to understand what it means. We've also discussed about the intersection of sets. It's a set of elements which are common, found, or say we talk of the elements which are found in sets under discussion. We've also discussed something about the complement of the set. These are just the sets whose elements are not found in a particular given set. So I've emphasized here to say this situation about the elements or complement of the set goes hand in hand with the universal set. Right. So by this we end. So what I'll do here, I'll just give you one exercise, just an exercise that to take you through and cover up what the discussion here. You know, all these things were already discussed in JCE, so here we are not even having much of the problems aside. So the exercise of which that I will need you gentlemen and ladies out there to write or say maybe just discuss is this. Just a simple one. You don't have to sweat. Let me just give you this one, I think. Exercise. Right. Suppose you're given that this is a universal set defined by, but now in the form of the set good annotation, x is such that x is less than 20, where x is an element of natural numbers. You're asked to list the elements of A. Set A that is defined by X is such that X is prime. I want the elements which are defined by this set. B, I need you to list the elements of X such that X is a multiple of A3, right? That is B. C, I'll need you to work out on the following. C, you're going to work out on this one. Complement of A. D, you have to work out on the A union B, right. Then the last one, DE, that's for your discussion. You need to work out on, just add one question here. Work out on the A intersection B, right. So by this, if you are there to follow what we have discussed, you'll be able to be in line with us in the discussion, and I hope that you understand what it is about the investor set, complement of the set, union of the set, and also the talk of the what? Intersection of sets. Right. Thank you very much for being together, and I hope that what we are discussing here, it makes sense and it gives you some kind of a direction on how best we can understand issues about the set theory. So keep on revising now and again until you get the sense if you still have problems in sets. Right, so what we studied up in JC is not very much new here in MSc. Right, so please let us go back and revisit the videos now and again, now and again. You can pray now and again until you master the concepts. In the next discussion that we meet in the other video next time, it'll be about the Venn diagram, and also there we'll be discussing issues about calculating the number of elements in a given set. Right, the last part of which it'll be just like application of what? That's the knowledge that we have just discussed in the set in handling up the real life type of problems. Right, thank you very much.